Hello, I'm Dr. Peter Carter from British Columbia in Canada. This video is focusing on the United States with respect to food security. The question and the study of the video is the United States food security vulnerable to global climate change? What the video shows is that continuing to burn more carbon will ruin our best food producing lands. It's like burning food. The world economy and our leaders are intent on the destruction of world agriculture because they're intent on burning more and more carbon. In fact, they are already committing us to a world of declining crop yields in all regions. I'm going to put up a few maps of cropland intensity and food production. They're self-explanatory, so there'll be no narration, and you can switch back and forward between the maps, put them on pause, and of course you can refer back to them as you watch the video. This is the first one, and we'll carry on. This is a 4°C world. This is a map that was published in 2009 by the New Scientist based on similar maps published by the UK Met Office. This map shows regional temperature increases. The 4°C world is a 4°C global average temperature increase since pre-industrial, it says here, relative to 1890. And obviously the redder the map is, the higher the temperatures are. This is the 4°C world map looking at the North American continent. One of the reasons why the maps were published by the UK Met Office in 2009 was the year of the Copenhagen Climate Agreement. This is one of the media coverages from the Telegraph in the UK on the publication of leading scientists saying that if there is a weak agreement, even let alone no agreement, temperatures may rise 4°C by the 2060s. The Climate Interactive Scoreboard provides this thermometer-based visualization. From the climate models, the Climate Interactive Scoreboard calculates confirmed proposals by governments, national proposals. What is the global temperature increase that the world is committed to at the UN negotiations? On the Climate Interactive's Climate Scoreboard, on the bottom here, we have the goal. The goal is a 1.5°C global temperature increase limit from the pre-industrial, and yes, 2°C is definite catastrophe. James Hansen and others have published that 1°C is now clearly the danger limit. Next we have the proposals, and these are all the latest proposals confirmed by the governments. These are the combination of national proposals, and they put us at a commitment today of a catastrophic global temperature increase of 4.5°C. If we carry on business as usual as we are, and every indication is that that is what nations are going to do, we arrive at a temperature increase of 5°C by 2100. This shows what a 4°C global average temperature increase world looks like for the North American continent. This was put out by the UK Met Office. It's on Google Earth. It's still on there now. And it's designed to show the regional temperature increases. I put this map of the North American crop intensity regions next for comparison. This is a 4°C world from pre-industrial. This region here is warmed up 6°C. This 6°C also, and the rest of the US pretty well is warmed up 5°C. So if we look at the best food producing regions, they are all covered with this 6°C temperature, regional temperature increase, and this goes right up to Canada. And so we'll be looking at these in particular in this video. We're starting with a very large unincluded effect and risk of global warming, in particular on food security, and in particular food security in the Northern Hemisphere. What is going to be the effect on Northern Hemisphere and United States food security when the Arctic summer sea ice and the snow has all melted away? Obviously, it's going to change the climate of the Northern Hemisphere, and that particularly applies to the United States. The scientists say that there will be an increase in droughts and there will be an increase in climate variability. Now that's very important because the world's best producing food regions are in the Northern Hemisphere. This image shows the extent of the Arctic sea ice and snow albedo cooling effect in the springtime. Today's rapid loss of Arctic snow and sea ice summertime albedo cooling should be treated as a dire emergency, certainly to the Northern Hemisphere, and that certainly applies to the great food producing regions of the United States. This is another 4°C world map from the UK Met Office, and this shows changes to crop yields and water resources. These big circles here are reducing crop yields. So 3 of the top food producing regions in the Northern Hemisphere suffer falling crop yields in a 4°C world: the United States, India, and China. We're now going to look at some temperature increase projections, some regional temperature increase projections for the United States, and we can do this by means of an excellent online climate tool called Climate Wizard at climatewizard.org. The models and the calculations are provided by climate change experts at the University of Southern Mississippi and the University of Washington, and this is a Nature Conservancy combined project, and it really is excellent. We're using the UK Met Office Hadley Climate Center model. This is a higher emission scenario, which is A2. We're actually on an even higher one, which isn't on the Climate Wizard. That's A1F1, but that's fine. A2 does for a high emission scenario. Temperature increases are from 1961 to 1990. So to convert to the International Pre-Industrial Standard, we add 0.25°C to that. The Climate Wizard gives the increases in degrees Fahrenheit, so we have to convert to degrees centigrade again for the international standard, and there is a temperature increase thermometer with the 2 scales, and this is from the National Research Council. This map is change in temperature by the 2050s. This large region of deep orange here, and obviously this corresponds at least to a large degree to the best grain producing region of the United States. This is a 6°F on this scale increase that converts to a 3.5°C increase, and that is a 3.75°C increase from pre-industrial. So that's right across there. This deeper orange here is the highest increase by the 2050s. That works out to 4.25°C. This lighter orange here, which takes up the rest of the United States, is 2.75°C. This lower temperature increase here with the lighter orange and down towards Florida is 1.75°C. increase. This is really what we're interested in. Here's the map of the North American crop intensity regions, the best food growing regions. So we compare that with the regional temperature increase by the 2050s. So we already see, very unfortunately, that the region of the greatest temperature increase in the United States is also the region of the greatest crop and food producing intensity. I can make that even more obvious by grayscaling the best food producing regions and then removing all the rest of the continental United States and doing an overlay. So there's the overlay, and as you can see, all of the best food producing regions, I'm afraid, are pretty well covered by the highest regional temperature increase region. So that remains to look at the region here on the west coast of the United States, which is heated up the most of any region. And of course, you know where this is. This is California, and this right here is where the very best vegetables, fruits, and nuts producing region is. This is the change in temperature by the 2080s, same UK Hadley Met Office model, same high emissions scenario, and it's immediately totally obvious now that all of this highest regional warming area is all of the very best food producing region in the United States. California again here, This is all heated up the most of any region in the US, and that's a regional temperature increase of 5 degrees C. The question, of course, is what do these regional temperature increases mean that we've discovered from the Climate Wizard site? These are the Ipcc 2007 climate crop model results, and these are for mid and high latitude, so that's the United States. On the top here we've got maize, in the middle here we've got wheat, and here we've got rice. And these are mean local temperature changes, so that correlates with the regional temperatures that we've been looking at for the Climate Wizard, and they're relative to 1990, and so that correlates with the temperature increase from Climate Wizard. So we've got a direct comparison here to discover what it really means. And what we find is that all crops are declining at a temperature increase of 2.5 degrees C. So there's 2.5 degrees C, and after 2.5 degrees C, they're all started to decline. Maize has been declining for quite a long time. And rain-fed wheat, which is included here in the Ipcc, has been declining since temperature increase of 1.5 degrees C. They have all declined below the baseline of the 2000 crop yield output at a temperature increase, this is local temperature, 1990, of 3.5 degrees C. So back we go to the Climate Wizard, the annual temperature increases by the 2050s. And we have this direct correlation because these are regional increases, and they're from 1960 to 1990. And so I've left the original from 1961-90 increases, and they're just converted to degrees C. So at a temperature increase of 2.5 degrees C, all of the crops are into decline. So that's this region, California, this region here, and all of this region here into decline. At a temperature increase of 3.5 degrees C, they've been into decline for a while, and now they have declined below the baseline. So the regions are producing less food than they're producing now. And that applies to the California region, and it applies to this big central world's top grain producing region. People are losing food, and this is by the 2050s according to the crop models. Crop models most likely are underestimating, as the National Research Council says, because of all the adverse effects that they don't factors capture in this video in particular. And so what is there left to say? By the 2080s, all of the regions have been losing food progressively as the temperature's been increasing, losing more and more and more yields. We're now looking at increasing dry days by 2100 as global warming increases. This map here is from the 2007 last Ipcc assessment. This is just the northern hemisphere in comparison. The best crop producing regions in the world in the northern hemisphere, and immediately see that all of these best regions, North America, Europe, India, and China, are all affected severely by increasing dry days. This, as I say, is by 2100, but it shows the trend that will occur from now on as global warming progresses. We're now focused on the North American continent, and the first thing to see is that the entire continent of North America, under progressive global warming, suffers a progressive increase in the number of dry days. Now, what I've done here is to take a block, the block that covers the best food-producing regions in the United States, and that correlates with a block that is severely affected by the most number of dry days. So you see that a large proportion of the food-producing areas of the United States are going to suffer the greatest increase in the number of dry days as global warming progresses. This graph here is from the most recent global climate change assessment, a fairly comprehensive assessment actually, which was published in 2010 by the National Research Council, called Climate Stabilization Targets. This is their published result of climate crop models. Vertical axis is yield change of crops, the most important crops, and the horizontal axis is the temperature. The temperature increases up to 4 degrees C and includes a few other climate crop effects as surrogates. The National Research Council provides the results in terms of the most important cereal grain according to several different countries. We're going to look at United States and maize, which is the one on the top, and it's in red. And as we do, we'll get quite a shock because United States maize does very badly under global warming and climate change. There's the US maize isolated from the rest of the countries. We'll start by taking a look at the what I call infamous 2 degrees C target. These are temperature increases from pre-industrial. We'll see that US maize has dropped in its yield by 30%. We'll now look at the 4 degrees C increase, which is what the combined national emissions policies or lack of policies have committed us to today. And we find that that reduces United States maize output by 60%. So our leaders have been targeting a global temperature increase that would result in a 30% decrease of United States corn output. And today they have us committed, because of lack of policy to meet their catastrophic 2 degrees C target, they now have us committed to a 60-degree drop in US maize. This is food catastrophe, obviously. You'll remember that many of the adverse factors are not captured in the climate crop models. One of those factors, extremes of heat or sudden spikes of heat, that are not in the models because the models are based on a linear projection of global temperature increases. This is taken from the National Research Council's 2010 publication, and this is the percentage of summers warmer than the current warmest summers. This is 2 degrees C global average warming, so this is what our governments have been targeting for us and still are. And clearly, almost every future summer is as hot or hotter than the hottest people have ever experienced today, and the hottest that our crops have ever experienced today, therefore. This is a study that looked at those particular extreme highs for United States food productivity. It was published in 2009. The title of the paper gives the message, "Non-linear temperature effects," and that's what these spikes and highs and extremes are, indicate severe damages to United States crop yields under climate change. It points out that the United States produces 41% of the world's corn and 38% of the world's soybeans, which of course is huge, you know. These crops comprise 2 of the 4 largest sources of caloric intake produced and are thus critical not only to the United States food supply but to the world food supply. We get a better look by just looking at one of the graphs. This one is soybeans. They're much the same. So here's the temperature increasing progressively, and as the temperature increases up to a certain amount, there's a modest increase in crop yield productivity. But when it gets to a certain point, a very specific point above the temperature which was improving yields, then there's a pretty precipitous drop in yield output, which increases, of course, as the temperature then gets higher. The finding of their research was that average yields are predicted to decrease 63 to 82% under the most rapid warming scenario A1F1, which is the scenario that we are fixed on. And this is by the end of the century. So from now, for the rest of the century, as global warming progresses, there will be more and more and more of these non-linear temperature increases that will do more and more and more damage to United States crop productivity. We're finishing this video with drought, and I want to remind ourselves that Drought was not captured in the climate crop models that we looked at earlier, with the linear projecting global average temperature increases and moisture changes basically. And so this has to be considered on top of the terrible impacts that those climate crop models indicated. This is a study published in 2010 by ADAI, D-A-I, using the UCAR climate models in the United States. The paper is called Increased Drought Due to Increased Global Temperature. The paper projected a number of scenarios at differing time frames in the future, right up to 2100. We only need to have a look at this one. This equates to a 1.8 degrees C global average temperature increase, which is even lower than the climate catastrophe target of 2 degrees C that our governments still have us stuck on. This is the Northern Hemisphere again, and it's immediately obvious that the best food producing regions in the world, most of them are mostly hit very badly. So this is focusing on North America, and clearly, the best food-producing regions in the United States are hit particularly badly by drought, and most particularly badly across in California. But also right up to the grain belt through to Canada is hit badly by drought. And this, I would mention again, is only a 1.8 degrees C global temperature increase. This is a paper called Projections of Future Drought in the Continental US and Mexico, and it's from the Lawrence Berkeley National US Laboratory. This is future drought projections under global warming and climate change. This is by the end of the century, but it's a mid-range scenario, so it's going to be decades in advance of that. Again, we're looking at the trend, and the trend looks especially bad for drought in the very best food-producing regions of the United States.